Here's something odd. Trees communicate. Now, it's not in the same way that you and I would communicate. Perhaps it's a little bit more primitive, or perhaps it's a little bit more complex. But either way, it's very alien. About 6 inches under the soil in almost every densely vegetated area, like a forest, there is a vast network of communication. These are known as mycorrhizal networks. Mycorrhizal networks are made from a collection of mycorrhizae, which are a type of fungus. Each mycorrhizae is in a symbiotic relationship with at least one, and possibly hundreds or thousands of different plants. They are present about 6 to 8 inches under the soil, where the roots are in highest concentration. Mycorrhizae will forcibly insert themselves into the roots of various plants, breaking the cell walls. This will open a kind of line of communication between the mycorrhizae and the plant that they are attached to. Mycorrhizae are adapted to be able to pull nutrients from the ground much more easily than roots, and will exchange carbon, nitrogen, phosphorus, and water for sugars and other things that the plant sees fit to trade in return. But mycorrhizae are so much more than just a relationship between themselves and the plant. Each mycorrhizae is connected to hundreds of other mycorrhizae that are connected to hundreds of other plants, and this forms a mycorrhizal network. See, the transportation of almost any compound or element can happen in a mycorrhizal network, in any direction. Plants can insert carbon and nitrogen and whatever else into the network, and will diffuse through the network until it is inevitably consumed by another plant. So if a tree has an overabundance of carbon, it will offload it into the network, where it will be consumed by some other plant that needs it much more. The mycorrhizal networks act like a pool of resources that can be taken from and added to as necessary. This increases the health of the forest and all of the vegetation in it, because if attached to a mycorrhizal network, any plant will be able to, in essence, trade their surplus of a specific resource for a resource that they need. Now, because there is a surplus of nutrients just sitting there, a plant that does not feel like doing any work but wants to reap the reward can. One such plant is called the phantom orchid. Unlike most plants, the phantom orchid does not have any chloroplasts, which means it will not undergo photosynthesis. This leads to the phantom look that they have. The way that they survive is by being connected to the mycorrhizal network and simply extracting the nutrients that they need. Thankfully, in most forests, there is not an overabundance of these plants that abuse the network, so everything works out smoothly. While one aspect of mycorrhizal networks is this resource sharing, there is a communication aspect as well. Mycorrhizal networks will allow for pheromones to be passed through them. Pheromones are compounds that are synthesized by plants and allow them to elicit some kind of response in another organism, normally of the same species. Plants can give off pheromones in many ways, but one of the most effective ways, as you may be able to guess from the topic of this video, is through mycorrhizal networks. Suppose a plant is being consumed by a caterpillar. This is not great for the plant, so it starts to produce an insect repellent. By the time the repellent is in high enough concentrations, the insects will have likely moved on. But plants will give each other a heads up by releasing pheromones. They release pheromones into mycorrhizal networks, and plants are able to pick up the chemical signals and will start to proactively produce insect repellents themselves, so that they will be ready by the time that the caterpillars roll up into their joint. This is extremely beneficial because it allows potentially devastating insect invasions to be stopped, all because of communication between plants. While mycorrhizal networks may seem all happy-go-lucky, it's not just sunshine and rainbows for plants. Just like in human communication, plants can be downright hostile to each other. Plants will produce alleochemicals and release them into mycorrhizal networks. Alleochemicals are compounds that have detrimental physiological effects on other organisms. Have you ever walked into a eucalyptus forest? If you look around, the lack of diversity is somewhat eerie. Eucalyptus produce extremely potent alleochemicals that destroy almost all other plant life. While this is on the dramatic end of the spectrum, in many forests alleochemicals are still used. Some pathogenic plants such as vines are detrimental to the trees, so in response, trees release alleochemicals into mycorrhizal networks that target different species of vines. And they do this in order to prevent their growth and attempt to kill them before they inflict too much damage. Mycorrhizal networks provide a free-for-all communication in forests. From resource pooling to communication about threats to chemical deterrence, a vast network of communication is actively being used. Mycorrhizal networks are so important to plant survival, any species opting out of the mycorrhizal networks has almost zero chance of survival. Every tree, every bush, every grass or flower, or anything else with roots is connected to these networks. And it's this interconnectedness that allows for the dense and diverse vegetation of forests and other places to be possible. If you enjoyed this video, or didn't, please consider subscribing. It would really help with my desire for validation on the internet.